Hello guys, today's lesson we're looking at chemistry practical question 2, WAEC, alright, by your host, the Kenga. Now, but before we proceed, you need to understand that WAEC chemistry practical, that's paper 3 or thereabout, is basically based on three sections. It's divided into three sections, alright. You have the volumetric analysis. This is the part A, question 1. Question 2 is the qualitative analysis. Then question 3 is general practical questions in chemistry. Alright, so for now, I've there are some questions that may likely be asked in the forthcoming WAEC. So we shall go through them one after the other. Now, this is the question 2. It says C is a mixture of an inorganic salt and an organic compound. Now, carry out the following exercises on C. Record your observation and identify any gases evolved. Okay, so state the results you draw from the results of each test. That's your inference. Now, put all of C in a beaker and add about 10 centimeter cube distilled water. Stir well and filter if necessary. Now, let's move to okay. Now, let's look at question 2B. 2B. All right. To about 2 centimeter cube of the solution, add add sodium hydroxide in drops, then in excess. Now, to another 2 centimeter cube portion of the solution, add liquid ammonia. All right, that's this liquid ammonia in water in drops, then in excess. Now, to another question B3, to another 2 centimeter cube portion of the solution, add HCl, then barium chloride. Now, you can see that I'm having 2, 3 here because the question might come out this way or the other way around. Okay, so it says to another 2 centimeter cube portion of the solution, add barium chloride, then HCl. What's the difference? It means that here HCl is coming first, then barium chloride. While on the other hand, barium chloride is coming first, then hydrochloric acid is following. Now, question 2B4. So another 2 centimeter cube portion of the solution, add Pelling solution plus U1. Alright? U1. So the questions might come out this way in any way. Questions might come out this way. Alright, so let's go to the next slide and we talk about the answers. Now, for the first question, that's question 2. It says test. These are your table will come look like test, observation, and inference. So the test is your methodology, whatever you are doing. The observation is what you see, and the inference is what you think is there. All right. So the first thing is you dissolve the sample in water. So that's C plus water. Now what happens? It dissolves in water to give a blue solution. Now the specimen given is you have glucose and you have copper sulfate. Now, copper sulfate and glucose are both soluble in water. So, in this kind of experiment, I'm not expecting to filter. So, you may not be asked to filter. Okay, but I didn't say you will not tell you to filter. But you may likely not be asked to filter because the two of them are very, very soluble in the water. So, you may just have to go on with your test. Now, so let's continue. Dissolve in water to give a blue solution, of course, because of copper present in it. Now, so what is your inference? You can say C is soluble in water, or you can say C is a mixture of soluble substances. Okay, depending on your choice. Now, you may also ask to test the solution with litmus paper. So what happens? So now say C aqueous. Can you see the difference? This one is ordinary C. That's you can put solid here. That's ordinary C. Now C aqueous means plus litmus. So your litmus paper will be blue or red. Now it's going to turn blue litmus red. So C aqueous is acidic. Why is it acidic? Because copper sulfate, when dissolved in water, gives acidic solution based on hydrolysis. Now let's move on to the next question. So for the next question, this is what we're going to be doing. So the first portion, it means that you will be given a test tube. You're going to add about 10 centimeter cube first. Then it's going to be a little bit much, right? Then you are going to now divide. You now be taking small portion from it. So small portion into another test tube to run your test. So you don't do your test with the textbook that has the whole bulk solution. So you just be fetching small and doing your test. So for the first portion, you are going to add plus NaOH in drops. Mind you, this NaOH is aqueous because it's not solid, so it's aqueous. Now, what happens when you react it with NaOH? We are going to get blue gelatinous precipitate. So when you see blue, especially when you are testing for metal, it's most likely copper, copper to iron. Then so you don't write Cu2 plus present, but you don't have to write a Cu2 plus actually. That's Cu2 plus raised to power 2 plus please. Now, in excess, the next one, same sample that you have that you poured the NaOH, you just pour small. Then you now add plenty again to see if there's a difference when you add much of it. Now, so what happened in essence is insoluble in essence. So you can still say that Cu2 plus is present. Now, the next test, second portion. So you now take from your bulk sample, you will discard that one. You may rinse the test tube. Then you now take another portion from the bulk solution you made in the first place. Now, you now say second portion plus NH3 in drops. Please, NH3 in aqueous actually. NH3 aqueous, that's liquid ammonia. In drops, what are you going to see? You are going to see pale blue gelatinous precipitate. Now, so what are you going to say? What is going to be your inference there? It means copper 2 plus present. Now, you poured liquid ammonia small, not too much, so in drops, like drop price. Now you now have to pour it in excess, plenty. So when you now pour it in excess, what will happen? The solution dissolves. All right, it dissolves. That is soluble in excess to give a deep blue coloration. So you are going to see a deep blue coloration from precipitate to a solution. All right. So that means Cu2 plus is confirmed. Now, why are you having a deep blue coloration and a solution? Because of the copper complex formed here. All right. So let's move to the next. Right. Now, let's look at the third portion. What are you going to use the third portion? Now, this portion is just to test for the negative ion that is present there. Now, look at it. We have third portion here plus ACl aqueous. Now, what happens when you react with ACl? There won't be any visible reaction, okay, because there is no effervescence. So it means that carbonates, sulfide, and triazosulfate 4 ion are absent. Alright? Because if they were there will be effervescence of the gas. Alright? Now, the next step is to add barium fluoride. Where are you going to get white precipitate? Now you now see SO42 minus confirmed. Or third portion plus barium fluoride, white precipitate. So we are going to get CO3 2 minus, that's carbonate ion, or SO42 minus present. They are the only ions, okay, they are part of the ions that give white precipitate the barium fluoride. Alright. Now, but when you have HCl, what happens? Precipitate is insoluble. So when precipitate is insoluble, it means SO42 minus is present. But if the precipitate has been soluble, it's not SO42 minus, it's CO3 2 minus. Now let's look at the last question. Okay, now the fourth question. Now, what are you going to do? Same thing, you're going to take small portion, maybe the remaining portion actually, of the bulk solution you made initially. Alright. So you are going to add for the solution. Then you are going to run. So this experiment should be done in a boiling tube. I think you will pour it in a boiling tube, then you hold it with the crucible. So now, what happens after boiling? You are going to see a brick red precipitate or red precipitate formed. Now, what's going to be your inference? Either you write glucose, or you write easy sugar, or you write ethanol is present. Okay, thank you. Now, disclaimer: the above solution is a guesswork. All right, it may not be exactly the same with what WAEC research. Right, we are just guessing based on the specimen available. Success.